Welcome. We want to take a look at an example of an application of quadratic equations. For this example, we would like to use Pythagorean's theorem. So just a quick reminder of Pythagorean's theorem here. So if I have a right triangle who has side lengths, let's see here, A and B, and hypotenuse length C, then according to Pythagorean's theorem, A squared plus B squared is equal to C squared. So we're going to use that in our application here. A wire extends from the top of a pole to the ground. The distance between the base of the pole and the ground level end of the wire is 23 feet greater than the height of the pole. The length of the wire is 1 foot less than twice the height of the pole. We want to find the length of the wire and the height of the pole. And in order to use Pythagorean's theorem, we're going to assume that a right angle is formed by the pole and the ground. So let's draw a picture that looks similar to our triangle. So here's a pole. Excellent. Maybe it's a utility pole. That's where your power lines run through, telephone wires, that sort of thing. All right, so here's the height of our pole. We'll call it X. Be a good idea to declare that. X is the height of the pole. We want our communication to be clear, so we'll write that down. Now we have a nice triangle drawn. So we have our pole, we have our ground, and we have the wire. The pole has height X. We know that the distance between the base of the pole and the ground level end of the wire, base of the pole, ground level end of the wire, is the height of the pole plus 23 feet. We also know that the length of the wire, that is the hypotenuse, is 1 foot less than twice the height of the pole. Twice the height of the pole, subtract 1. Now we go ahead and apply Pythagorean's theorem to create a relationship between these three side lengths. This gives us x squared plus x plus 23 squared is equal to 2x minus 1 squared. Expand the square on each side, so x squared plus 46x plus 23 squared, which is 529. And expand the 2x minus 1 squared to get 4x squared minus 4x plus 1. We can simplify on the left-hand side just a little bit here if we wanted to. We can write it as 2x squared plus 46x plus 529 is equal to 4x squared minus 4x plus 1. That just helps us recognize that we can subtract the 2x squared instead of subtracting x squared and then subtracting x squared again. That would be a little bit silly. Anyway, so we can subtract the 2x squared, the 46x, and the 529, of course, from both sides to obtain 0 is equal to 2x squared minus 50x minus 528. Now, I chose to write it in this way, subtracting the 2x squared, so that way I would have a positive coefficient here. The reality is it probably didn't matter at all because I noticed that now that they have a common factor of 2, they would have simply had a common factor of negative 2 instead if I'd have done it the other way. I want to pull that common factor of 2 off so that way I can more easily solve this quadratic equation. Let's see here. Half of 528 should be 264. Here we go. So this might not factor easily, but if you write out the prime factorization of 264, it does actually become pretty quick to observe that this does factor nicely. I would encourage you to either use, to try and factor it or to use the method of completing the square, that sort of thing, to try and solve this. Integer coefficients, each of these options are pretty reasonable. Shouldn't need the quadratic formula. Anyway, this does factor as x minus 33 times x plus 5. I'm sorry, not x plus 5, x plus 8. That makes more sense. 33 times 8 will give us that 264. And negative 33 plus 8 will give us that negative 25. Excellent. There we go. This tells us that we have x minus 33 is equal to 0, or x plus 8 is equal to 0. So x is either equal to 33 or x is equal to negative 8. Now we should ask ourselves, which of these makes sense? Does it make sense for us to have a pole that's negative 8 feet long, that is 8 feet into the ground and doesn't extend upward? It doesn't make sense. Right, we want that pole that's has a height of 33 feet from the ground. From ground up 33 feet. So this is the answer that we want. We don't want the negative version. We can observe then that 2 times x minus 1, the length of the wire itself, is equal to 2 times that 33 minus 1, which is 65. 66 minus 1 is 65. We should give a complete sentence response since it's an application problem. At least that's the ideal. So we would say the length, let's see here, L-N-G-T-E-H, there we go. The length of the wire is 65 feet. And the height of the pole is 33 feet. Excellent. And that's what we were looking for.